Hi all, this is Mr. Yeager for chemistry. We're looking at a topic on significant figures, which is probably one of the least favorite topics of any chemistry class, but it's something that we have to do and we will use through the rest of the year in our calculations. So we better just get to it. So this is a method to illustrate the amount of uncertainty in measurement. It's the way that we figure out how many digits we round to is really the main point of it. But the underlying purpose of it is it tells us how accurate and how precise our measurement actually is in the end when we use it and when we do our calculations as well. So when it says, what does significant mean? It means that these numbers are important to the measurement, all right? That we need to be able to, we have to record them when we do our measurements. These are done in the laboratory, in real life, all the time in terms of how we officially measure in real chemistry and all scientific research in the end, all right? It's just we really kind of hammer it in this particular course. It is something that should transcend all courses, but it is something that we definitely kind of really point out since we're using so many very, very small numbers. We have to be very, very careful of keeping all the ones that are, as we say, significant. So there's always some uncertainty in a measurement. When you take a measurement in the lab, all right, and you look at a ruler or you look at a graduated cylinder, you have the little tick marks in terms of going, I can measure out the size or the length of this particular object, okay, or this mass or anything, again, you're taking measurements of. The thing is, there's always that little bit of space between tick marks. And so when you might be like, hey, I'm measuring this at 10.2 centimeters, somebody might be measuring it at 10.3 centimeters because it's right in between the two tick marks. So that's what we're looking at with this uncertainty, is that you are adding in this one extra digit that's kind of saying, this is approximately where we are with a little bit of uncertainty between those two numbers, okay? So that's what this is saying. We always have a little bit of approximation, and there's always a little uncertainty with that measurement. All right, as I pointed out, the uncertainty always lies in the last digit of measurement. So if I measured the mass of something, 2.361 grams, then where is the uncertainty? It's in the 0.001 gram. It's in the thousandth place of that particular measurement, where we might be like, it might be 2.360, it might be 2.361, or it might be 2.362, but we have a little bit of uncertainty. So that's what we're saying, plus or minus that last digit. All right. So again, we never ever really say that we have a completely accurate, precise measurement. There's always a little bit of uncertainty around it, and so that's where the significant figures comes in. So with the volume example, you measure something to 1.236 milliliters. You are saying that last thousandth digit, the 6, could be plus or minus 1 if necessary, okay? So that's the meaning behind it. We're not going to really apply that in great detail. It's more about just pointing out that that's the digit that has a little bit of uncertainty. So the goal of taking measurements is that we have confidence in that scale that we're measuring, that we are taking accurate measurements, that we are consistent, that we are precise, all right, and that we are trying to do essentially the same thing over and over and over again, all right? So this allows us to have uncertainty is actually a good thing because it's telling us how close to the measurement we actually are getting with it, all right? And so we account for that using what we call significant figures. All right, so how do we figure out the number of significant figures, okay? What we look at is every single non-zero digit, so every single number, 1, 2, 3, 4, 5, 6, 7, 8, 9, are significant figures, are significant numbers, okay? It is the zeros that we have to pay attention to and determine whether they are significant or whether they are not significant. Now we could go through all these different kind of like variations of the rules. There's like 4 or 5 different rules, or we can follow what we call the Pacific Atlantic rule, or not rule, but trick. I don't know what else to call it. Pacific Atlantic rule. We'll just call it that. Look at that. It's called the Atlantic Pacific rule. So anyway, what you're looking for is when you're given a number, And you're going to have to do this in all your calculations again from here on out. So we got to figure this out. Otherwise, you're going to keep on losing some credit for your calculations. All right, you might not be marked off completely depending on your class, but you will be marked off for some credit, I would assume. So what you're looking for with this little Atlantic Pacific rule is we're saying you're looking for a decimal point. If you see the decimal point, we say the decimal point is present, and we're going to start from the left of the number, and we're going to start at the first non-zero number and count everything out from that point forward. Again, that might not make sense until I get to an example. But if we see a decimal point, you are starting from the left and counting all the numbers. You have to start with a number that's not zero and count all the ones from that point forward on in. If you do not see a decimal, we say it's absent. That's where we get the Atlantic part. You're going to come from the right side. So we're thinking of this from which side is the Pacific on the United States? If we look at a map, the left side, Atlantic's on the right. So if you don't see a decimal point, you start on the right-hand side and you go through the number until you find a non-zero number, and then you count every digit from that number forward. So here we go. So we have an example, 123,000. So I do not see any decimal point. Okay, there is no decimal point here. All right, that means I'm going to start from the Atlantic side. It's absent. And so what I do is I start moving through this number. 0 is 0. It's not zero. Okay, well, it is not zero, whatever. All right, so we keep going, we keep going, we keep going. I need to hit a number that's not 0, and I don't do that until I hit the 3. So all 3 of these zeros, we would say, are not significant. Now, you don't need to point that out in the end, but I'm just saying that to you. And then we just count up the rest of the numbers. 1, 2, 3. So we have 3 significant figures. We usually are shortened out to sig figs in this 123,000 number. 3 sig figs. All right? There we go. So we start from the right and we move on in until we hit a non-zero number, which is the 3, and count everything from there. So what about this one? 0.0006095. All right? So now I see the decimal point, so I'm going to come from the Pacific. So I start moving on in until I hit a non-zero number, which would be the 6. So I have 1. Hey, there's another 0. But I've already started counting, so I count that one. 2, 3, 4. So zeros can be significant if they're between 2 other numbers. Well, if they're after, I shouldn't even say between, if they're after our first significant figure, our first significant digit that we've counted. So there's 4 sig figs in this particular problem. All right, start from the left and move on over. More examples. 12.004. I see a decimal point. I start from the left. Actually, I'm going to put all these up here. Let's just get all these up here. Oh, shoot, it gives me the answers. Darn it. Okay, never mind. I start from the left, and I immediately hit a non-zero number. So this is significant, so everything after it is significant. So that's why it said 5 sig figs. Okay. The second one, 10,000. I don't see a decimal point. I don't care about commas. So I'm going to come from the Atlantic absent side, and I go all the way, and it turns out there's only 1 sig fig here. That 1. All the other ones are zeros before I hit a real number, so therefore they don't count. 1 sig fig. All right. What about 11? I don't see a decimal point, so I should start from the right-hand side, and I immediately hit 1. Both of these are significant, so there you have 2 sig figs. One more. All right, I see a decimal point. I come from the Pacific because it's present. I go through the zeros, and I have 1, 2, 3, 4, 5, 6. Again, once I hit a sig fig, everything after it, if I'm coming from that side, is significant. Okay? More examples. Here we go. So, it's absent. So I'm going to go through all those zeros. This one I bet you is going to be 3. This one you have present. You come from the right, you stop at 2, 1, 2, 3, 4, 5. I have 5 sig figs. I have a present decimal point. I come from the right. I immediately hit a number, so everything is significant. And then 10,001, I do not see a decimal point. There's no decimal point there, so I come from the Atlantic, absent. I immediately hit a number, so all of these numbers are significant. This one's also 5. So 555 there. Okay, so 3, 5, 5, 5, 3, 5, 5, 5. I'm so smart. All right. So, how are we going to then apply this? Because yes, you might get a couple questions just going, okay, how many sig figs are there, just so that you understand. But now we're going to be using it in the chemistry, in the math. We only are going to be doing multiplying and dividing calculations essentially the rest of this year. If we have any addition, subtraction, we might come back and talk about it, but the only type of significant figure math I'm interested in is the multiplying and dividing. Okay? All right, so when multiplying and dividing, the correct number of significant digits in the answer is the same as the measurement with the least number of sig figs. All right? So what this is saying is you got to count how many sig figs there are in the numbers that are given to you, and whichever one has the least number of sig figs, that is the number that your answer has to be in. So this is where you're going to get in your calculator. You're going to calculate everything out, and it's going to spit out like a 8-digit number. You need to go, well, how many digits does the starting number have? Usually that's what we're going to have to, fortunately that's the nice way of looking at this. We can usually look at the starting number, at least at the beginning of this stuff. And that should be how many sig figs there are. If there's multiple starting numbers, whichever one has less sig figs. Okay? So the next slide goes, what? All right. So, jumping into an example with it. All right. What I would do with this, okay, is, and you can already see this is all done. You have 2.22 times 3.546. You plug this into your calculator, you get 7.67232 and probably more digits out of your calculator. What we have to do is we have to look at both numbers and go, okay, there's a decimal present, so I'm going to come from the left, and I have 3 sig figs in this number. There's a decimal in this one, so I come from the left, and I immediately count all of them. 1, 2, 3, 4. There's 4 sig figs in the second number. So, I have 3 sig figs in one, 4 sig figs in the other of my starting numbers. The rule states my final answer will have the same number of significant figures as the number with less sig figs. 3 is less than 4. So I need to round this down to 3 sig figs. So I'm going to keep the first 3 digits because, again, I'm coming from the left. It's decimal. 7.6, but then that last digit, that third sig fig, I have to look at the one next to it. It's less than 5, so therefore it stays as it is. I have to determine whether I round it up or keep it the same. 7.67 would be my final answer. All right, so I chose the number with less sig figs. That's what I'm rounding my final answer to, is 3 digits. I keep the first couple of sig figs in this number, and then I determine whether I round up or keep the number the same for the last digit. All right, and that's what this says. All right. If I'm dividing, same thing. Multiplication, division, we do the exact same thing. The nice thing is those two, operations work together. All right, are opposites of each other, so they're going to follow the same rules. Okay. So if I look at this one, I multiply 121 times 10 and I get 12.1 centimeters. Well, that's not necessarily my final answer. I have no decimal here, so I come from the right, and I have 1, 2, 3 sig figs in this number. In my second number, I have no decimal, I come from the right, I have to skip the 0, and I only have 1 sig fig, which means I need to round this number, 12.1, down to just 1 digit. All right, and I have it, yes, I have it as 0.1. I want to keep, obviously, the largest placeholder. All right, I'm not going to round it down to 0.1. It needs to make sense. So I'm going to keep this 1, and again, so I have 12. Will 12 round the 1 up to 20? No, it's going to round down to 10. All right. Now again, people make mistakes on this all the time when they first start. They're like, oh, the answer is 1. No, I mean, 121 divided by 10 does not equal 1. All right? I need to put 10 here, and this is only one sig fig, because if I don't put the decimal point and I come through it, just like I did with the first 10, there's only one sig fig in this, and that's correct. All right? So the number still needs to make sense. I can't sit there and be like, I'm rounding 12.1 down to 1. That's ridiculous. I can round 12 down to 10, and that still seems kind of silly, but that's the way it kind of goes with it. At least it's more accurate. Okay? So there we go. All right? We are not doing addition and subtraction. The only other thing I want to mention, and we're going to do a couple more examples with this, is if you are using any constants, okay, constants do not count for sig figs. Okay, significant figures. So we're about to do some molar math. When you calculate out molar mass, when you use what's called Avogadro's number, and again, you might be like, what the heck are these things? But, or if you're listening to this from a physics class, it's requiring you to do significant figures, and you know you have to use the the acceleration due to gravity, or the universal gravitational constant, or anything like that. We don't look at those in terms of figuring out our significant figures. Okay, we don't use constants. We don't use conversions. That's probably the other way to say it. Conversion factors. Conversion factors and constants are not accounted for in sig figs. You have to use your original starting number or any other numbers that are given to you in the problem that aren't constants or conversion factors. Okay? All right, so let's check out some other problems. Let's do a couple more, and then we'll call it. All right? So, we're not doing any adding and subtracting. Don't worry about that. Okay? There we go. Multiplying and dividing. All right. So, here we go. We're going to do like 3 of these. Oops, shoot. What am I doing here? Back to that. Give me a second. All right. What happened to my board? Ah! All right, well, I might just be talking with you. Here we go. I'm trying to, maybe it's stuck right here. Let me get out of this. You get to see me struggle for a minute. All right, well, I'm going to do this another way now. Here we go. So, if I do this, 1.35 times 2.467, my calculator says 3.3045 as the final answer. Okay? The thing is, I'm multiplying. How many sig figs do I have right here? There's a decimal, there's 3 sig figs. This one right here, there's a decimal, I come from the Pacific, there's 4 sig figs. So my final answer has to be in 3 sig figs. So I have this. I'm going to keep 3. I'm going to keep the second 3. I'm also going to keep this third spot. So 3.3, and then but I have to look at the next digit next to it. 4. 4, that doesn't round it up. So this is going to be 3.30 meters squared. Okay. All right, let's try the next one. All right, there you go, 3.3. I don't know why I said 3.3. Oh, sorry, I wrote that wrong. 3.33. So let's try that one again. I apologize. I'm flustered with this frustrating thing. So 3.33045. That was the final answer. So I'm keeping 3, 3, and then the 0 does not round the 3 up, so 3.33 meters squared. Okay? All right, next one. All right, 1,035 divided by 42. All right, I get 24.64285714 out of my calculator. All right, I look at the first number. There's no decimal point, so I'm coming from the right. I count it immediately. The 5 is significant, so everything 5 and on is significant. 1, 2, 3, 4. I have 4 sig figs. Then I look at the 42. I come from the right, no decimal point. 1, 2. So 4 sig figs and 2 sig figs. I need to round to 2 sig figs. So I'm only going to keep the 2 and the 4, but I need to look at the one next to the 4. So 20 and 6 is above 5, 5 or higher, so this is going to be 25. All right, would be our answer. There we go. All right, one more times, and then we'll do like 2 divisions. 1.234 divided by 0.247. I am getting, oh, this one's going to be fun to round. I'm getting 4.995951417. All right, I have a decimal. I immediately hit a number, 1, 2, 3, 4, 4 sig figs. I do not, I come from the left, there's a decimal. I don't count the 0, but I hit the 2, 1, 2, 3. I have 3 sig figs in this. Okay, so I need to keep the 4, the 9, all right, because I'm rounding down to 3. And then I need to keep this 9, but I need to look if I need to round it up. I do, there's a 5. So if I round that 9 up, that becomes 0, which I then add to the next one, which becomes 0, which I add to the next one. So this would be 5.00. And you have 3 sig figs. And this is all significant because you have your decimal point. You come from the left, there's a 5. So everything after it is significant. Oh, look at that. Perfect. All right, let's do like 2 divisions. 4.3 divided by 8.74. You can see, guys, that we're pretty much always going to round to like 2, 3, 4 digits. There's occasionally the one that's 1 just so that you're doing it right. But 0.491990847. All right, 2 sig figs here. Hopefully we're getting it. This one has 3 sig figs, so I need to round it to 2. So I'm going to keep the 0, and I got the 4 and the 9. I look at it, it's next to 1, so it's going to stay the same, 0.49. Last one. I'm not going to do multiplication. 150 divided by 4. This comes out to 37.5. No decimal. Come from the left. 1, 2. Oh, no, sorry. Come from the right. Ignore the 0. 1, 2. So 2 sig figs in 150. 4. There's only 1 digit, so there's only 1 sig fig. So I need to round this just to 1 sig fig. So I'm going to keep the 3, but I need to look at the one next to it. It's a 7, so that's going to be rounded up to 4, so this should be rounded to 40. Not 4, because 37 and 4 are not close, but 37 and 40 are. So that's your idea of doing significant figures. It'll take some time. It'll get annoying at certain points, but just follow it, get consistent with the rules, and you're good to go. All right.